Hi guys, welcome back. I hope again this video finds you well. So what we're going to focus on today is properties of logarithms. So the first property we're going to learn about is the change of base formula. Now this one isn't as useful for us as we've seen how to in the Desmos calculator. Just put our own base in there. However, on other calculators, you're not always able to make the base whatever you want. So this is how you can calculate or change the base to what you need. So, if I have log base A of B, that's the same as the log of B divided by the log of N. So whatever the base is, I take the log of that, and that's what I divide by. This is also equal to, I'm going to put an or here instead of an equal sign because I don't want any confusion there. You can use natural logs here. Natural log of B divided by the natural log of N. So that is change of base. So in the notes page, you do see an example of that. I'm not going to bother taking the time to do it because, frankly, at the end of the day, we're utilizing the Desmos calculator. I'm just showing you this for when you have a calculator that won't let you. So, this is useful, but it's not where our focus is. I want to focus on three other properties. These are much more generic properties, and these are really important ones. This will be useful not only in this class and when we start solving logarithms and exponentials, but will also be useful in calculus because if sometimes it can be very helpful if I'm integrating something to expand it out and take the integrals of individual parts and then recondense it together at the end, than doing more complex integrations with things that are condensed. So these work two ways. So it works going in both directions. So property number one we want to look at. I want that in a bolder marker. This one, I think it's a bolder red one. Yep. So property one says the log base A of U times V. So when I have multiplication inside my log, I can rewrite this as split up as log base A of U plus log base A of V. So if I'm looking to expand something out, if they're multiplied together, split them up with addition. Now if I said, well, I'm getting to the end of my answer, I want to condense everything, make everything a little neater looking, I could say, well, okay, since these are added together, I can take what's inside each log and multiply them together. That's property number one we're concerned about. Property number two, let me write this. Base. Property number two I'm concerned about is division. So if we think about it, if multiplication ended up getting switched up as addition, it would then make sense that division's the opposite of multiplication. Well, this should be the opposite of addition, so this will be subtraction. So when I divide two things inside a logarithm, that can be split up as log base A of U minus log base A of V. So I split those two apart now using subtraction. Again, when I am doing this, if I see these separated by subtraction and I'm wanting to condense, I could go, oh, that's subtraction, so make it u divided by v inside of 1 log. Now, the final property deals with exponents. These are the 3 properties we're going to focus on. This says log base a of u to the nth power. And this is a really helpful property, definitely once you get into calculus, because what I'm going to do is I'm going to say, hey, since this is u to the nth power, I can bring that out as a coefficient. And now if I'm just multiplying by some number, that can make my calculus less complex, as I can say, okay, I'm going to do all this work and then multiply by what I need to multiply in the end. So I don't have to worry about that number for as long. I can move it outside an integral even. Again, you'll understand more what I'm saying when you take calculus with like move outside of an integral. But it really does have some great applications in higher math. So this, the exponent now becomes a coefficient. So that'd be n times the log base a of u. So if I have this out in front, I can also say, oh, that's a coefficient in front of my log. Let's move it to the exponent inside. So these are 3 basic properties that we are going to utilize time and time again. So we're going to start with expanding. Like I said, sometimes with doing calculus, it could be easier to look at a complex log situation where there's a lot happening inside of it as a few smaller but simpler log problems. So expanding it out can make your math easier, and then you could condense. So example 1, we are going to expand this out. So when I expand, I want to go from this condensed form to it all being like addition and subtractions of various logs. So let's look at example 1. Example 1 says expand, what's the equation? The natural log of x times y to the 4th all over 2. Okay, so the first thing I want to do is I see in my numerator, we'll talk about the denominator in a second, x and y are multiplied together. So that's going to give me the natural log of x plus the natural log of y to the 4th. Now, I'm not taking care of my power right now because I just want to take this one step at a time for you guys. Now, since this says the whole thing's divided by 2, I'm just going to subtract the natural log of 2. Now, we could evaluate what the natural log of 2 is. I'm not going to bother. I'm just going to leave everything as natural logs here. Now, we're not completely done because I don't like to have exponents when I'm writing in expanded form. So now I'm going to utilize this. Since this y to the 4th as an exponent of 4, I'm going to bring that out in front as a coefficient to this. So when I do that, that gives me the ln of x, that stays unchanged, plus, now the 4 becomes a coefficient, so 4 times the natural log of y, since that coefficient got moved down in front, that's going to say minus the ln of 2. And that is fully expanded. So if I was doing some more complex calculus, I could look like, oh, I just need to take the derivative of this or the integral of it or whatever operation. Do the same thing here and here, as opposed to doing some more composition of function type things with integrals and derivatives, which become much more complex mathematically. So I'm able to, in this expanded form with higher math, take integrals and derivatives of each item individually more easily than the original item as a whole. So that's expanding. And expanding is great for, like I said, helping us with higher math. Now, constantly writing stuff out like this takes up a lot of space, right? So if we expand it out, we might want to recondense it for our final answer. So if I were to condense this, I'd get back to here. For the purpose of what we're doing, we're leaving that expanded. But we're going to look at another example on how to condense. So in order to condense logs, what we're going to do is kind of work that process backwards. First, I'm going to look to bring any coefficients in as exponents. All addition turns to multiplication. All subtraction turns to division. So example 2 says to condense three log of x plus 4 log of the quantity x minus 1. So I do want to bring up something very important with that first part there. So this x minus 1 is inside the log. Subtraction inside the log doesn't mean we can do anything. We only can do stuff with multiplication, division, or exponents in the log. We can do stuff with addition and subtraction when it is outside the log functions. So this x minus 1 here doesn't get changed at all. I can't really do much with it. I'm just going to keep it in x minus 1 the whole time. So the first thing I want to do, like I said, I kind of look to do these first when I'm expanding. I'm going to look to do this one first when I'm condensing. So I'm going to take these powers and move them inside. Now the entire x minus 1 goes to the 4th power. So I will have the log here of x cubed, the quantity x cubed, plus now the log of, I'm going to put this in a double set of parentheses, x minus 1 to the 4th, just to indicate the entire, just like the x minus 1 is to the 4th power. I'm not trying to do like for the 4th power of the log. So, here with this, I got one last thing to condense here. Since it's addition, I want to condense it to multiplication. If it was subtraction, I would make it a fraction. So here with this, my final step, I just want to say x cubed times the quantity x minus 1 to the 4th. So that's all going to hang out inside my log. So this now becomes log of x cubed plus times x minus 1 to the 4th. Now, I could do some things inside here. I could expand this out using a few steps of multiplication and then multiply everything in there by x cubed. That's really not very necessary. This is pretty neatly written here and much more, again, condensed than this. If I were to go backwards on this like I did in the first example, I would split them up as addition, then move the powers outside to get back to my condensed form. So, that is our bulk of the notes on this. Now, in the notes pages I give you, there is another page talking about applications of logs and things of that nature. For right now, I'm going to say just focus on these properties. Those applications are something we can look at a later date if we have time to get to them. Nothing inside your homework will deal with them. So we're just going to leave it at this. So, quick summary of the day. When we're multiplying logs, or when there's multiplication inside the logs, we can split them as addition. When we're adding logs, we can condense as multiplication. When we had division inside our logs, we can expand as subtraction. If we have subtraction, we can condense as division. And when we have a power inside the log, it can be pulled out front as the coefficient of the log. When we have a coefficient, it can be brought inside as the power. Thank you for watching and have a great day.